Hi students, in this lecture I am going to discuss variable mass system. Let us see. Till now we have taken that mass of a given system is a constant. But coming to here, let us take this is a system from which mass is going out, or you can say mass is entering into system. Then what happens is for the system mass changes. That is what we call variable mass system. So whenever mass is leaving the system, it exerts a force on system like this. Or when mass enters, this exerts a force in the same direction. For example, if you are taking a vessel which contains liquid, when liquid comes outside, it exerts a force opposite to direction of velocity, like this, right? Now same thing here. Whenever mass is leaving the system or mass is entering the system, an extra force acts. That is what we call thrust force. And the thrust force is given by it is V relative into dm by dt. It is V relative into dm by dt. That means relative to system with what velocity mass is coming out. That is V relative into dm by dt. If mass is leaving the system, then dm by dt is negative. If mass enters into system, then dm by dt will be positive. Okay, that means when mass is entering into system, thrust force will be along the direction of v relative. Okay, that means here with respect to system, mass enters with a velocity like this. So dm by dt positive. Therefore, force acting in the same direction. You can see here. When mass is leaving the system, its dm by dt will be negative. That means it is opposite to the direction of relative velocity. So relative to the system, mass is coming out. This is direction of relative velocity. But force is opposite to that. Okay. So if you want to use Newton's second law, earlier we have taken like net external force is equal to mass into acceleration, right? Now only extra thing is because of this mass which is leaving or which is entering having one extra force. So for all these external forces, take one extra force, that is thrust force. So remaining forces are as usual. For those forces, take one extra force. That is our thrust force. Now this becomes net force, which is equal to mass into acceleration. But see, in this, m stands for mass of the system at that instant, because mass is changing continuously. Maybe mass is leaving the system or mass is entering into the system. So at which instant we are focusing acceleration? Mass is at that instant. Acceleration also at same instant. Means these two are variables. That means now onwards, whenever mass of a system changes, we have to use now this equation. Net external force plus thrust force equal to mass into acceleration. Okay. Let us take one simple example. Take rocket propulsion. Rocket propulsion. Assume this is a rocket. Now it is ejecting gases down with a velocity ticket as v. That is v relative. Okay. relative to rocket. Let us take its mass is m naught when time is 0. At time t equal to 0, mass m naught. Okay. So we have to find what is velocity of the rocket as a function of time. Okay. Let us see how to solve it. Because of this ejecting gases on the rocket, thrust force will be opposite to the direction of relative velocity. Because ejecting gases means its mass is decreasing, right? So dm by dt is negative. So focus carefully how many forces acting on the rocket. mg downwards, where m is mass of rocket at one instant. Because of ejecting gases, thrust force will be upwards. Thrust force, right? Now these two are forces acting. Then see what we can write. Let us take up as positive because one is down and one is up. External forces. Gravity becomes external force because we are taking the rocket as a system. Okay. So external force. So minus mg. Thrust force, which is upwards, that is a positive. So I can write it as plus v relative into minus dm by dt. See why we have taken minus, because dm by dt itself is negative. So to make it a positive, we have taken negative sign. Okay. So this force downwards. So we have taken negative. Thrust force upwards. So we have taken positive. This net equal to mass into acceleration. In the place of acceleration, we can write it is a dv by dt. Now rearrange this. Mass gets cancelled. This is minus g dt. Next, minus v relative dm by m, that is equal to dv. Okay. Now integrate. When time t equal to 0, mass was m naught. At time t, mass is m. Initial velocity take it as u. Final value b. Now see calculation part. V minus u is equal to minus gt minus v relative dm by m. That becomes see how much minus v relative ln m by m naught. Rearrange this v equal to u minus gt. I am taking minus inside. So v relative ln m naught by m. So if you take initially velocity is 0, when u value is 0, right? So like this, we can use now this equation. Okay. Let us take one more example to get more clarity. Right. See the question carefully. Find the mass of a rocket as a function of time if it moves with a constant acceleration a in the absence of external forces. The gas escapes with a constant velocity u relative to the rocket and its mass initially was m naught. So this question is taken from Irdo. So we have to find mass as a function of time if it moves with a constant acceleration a, given acceleration constant, in the absence of external forces, right? The gas escapes with a constant velocity u relative to the rocket. Initially mass was m naught. See how we are starting the problem. So first we have to focus the equation. The equation is external force plus thrust force. This net equal to mass into acceleration. In this condition given A is a constant, right? And one more condition given that no external forces. So this is zero. Thrust force. It is given that with a constant velocity u relative to rocket. So it is u. Now I have to take here minus dm by dt. The relation is mass is decreasing. Ejecting gases means mass is now decreasing. That is equal to m into acceleration. Now rearrange this. I can write here dm by m, that is equal to dm by m, that is equal to minus a by u into dt. Now integrate at time t0. Mass was m naught. At time t, mass is m. Okay. Now see what happens. It is ln m by m naught, that is equal to minus a t by u. Take antilog on both sides. Then m equal to m naught e power minus a t by u. Right. So it is just substituting values in this. No external force is zero. Thrust force u relative into minus dm by dt equal to ma. Given a value constant. Okay. Right. See the next one. Right. See the question carefully. Determine the force P required to give the open link chain of total length L a constant velocity V, where V is dy by dt. This length equal to y. The chain has a mass rho per unit length. Neglect the small size and mass of the pulley and any friction in the pulley. So we have to apply force P downwards to maintain constant velocity required. The force P required to give open link chain of length L. Let us see how to start the problem. So first note down the given data. So pulley is given and we are given now a chain like this. Next remaining part. And this length equal to y. We have to provide some force P downwards, which we have to calculate. And this is equal to h. Now focus carefully. Let us take, let us consider up to here this part and again this part here. You can see by this part of the chain force acting on these two parts. And one important point given that velocity constant. Velocity v which is equal to dy by dt. Velocity constant. Then see what we can say. If you focus this a half ring or you can say half is just like a half circle, right? Since velocity constant, or I can say speed is a constant, on this one, there should be no tangential force. That means a force by this part of the chain here and by this part of the chain here should be same. Okay. So if I am taking that pulley and let us take the half part. If you focus the half part up to here, force by this chain, by this part of chain, and by this part of chain must be same. Then let force 0 along the tangent, it will have constant speed. Okay. Now coming to this part of the chain, say force is acting on this part of chain. By this chain on this one, it is F upwards. Its weight mg downwards. Its weight mg downwards. Mg means given rho, right? Rho into h. It is rho into h downwards, downwards. And if you observe, taking this as a system, taking this as system, you can see this chain is entering into system. When chain enters into system, you can see with respect to system, its velocity is downwards. See carefully. With respect to the system, see for this part velocity is 0. For this part velocity v upwards. With respect to system, its velocity is v downwards. Okay. And mass is entering into system. Therefore, thrust force will be downwards. Thrust force. Okay. Then see what we can write here. Since for this speed is a constant, net force must be equal to 0. So condition 1, F should balance rho into H into G. This is M into G, mg plus thrust force. See how to calculate now thrust force. Thrust force is given by V relative into dm by dt. So per second, how much mass is entering? Okay, per second, how much mass is entering? That is given by V relative, that is V. This will be given by lambda into, sorry, it is given rho, right? It is given rho, mass per unit length. Mass per unit length is given rho here. Generally, we are taking lambda for mass per unit length. But in this, it is given rho. Take rho only. It is a rho into V. Check one's dimensions. Rho is mass per unit length, right? Into velocity, just like length by time. So this is now mass per unit time, dm by dt. Okay. So this becomes now rho v square. Rho v square is now downwards. So rho v square downwards. Now coming to right part of the chain, right side. This length is y. Applying force P downwards, mg downwards. Mg means rho into y into g. Mg downwards. And by this part of the chain force acting on this part, it is F. Again F equal to, how much? It is P plus rho g y. Okay. Now equate this to, then see what we get. P plus rho g y is equal to rho h g plus rho v square. That implies P equal to rho v square plus rho g It is H minus Y. Okay. So here key point is it maintains a constant speed, right? So final answer is P equal to rho V square plus rho G into H minus Y. That is about question number 15. Let us take, there is one more question. It is in HC Vermam. You can see. Let us see once that question. That question is like you're having a chain of length, it is L, chain of length L. Now it is released from rest. It is released from rest. When half of the chain reaches the table, when half of the chain reaches the table, how much force does a chain exert on the table? How much force does chain exert on the table? Okay, then see what happens. When half of the chain has reached the table, so we have half part on the table. We want to calculate force by the chain on the table. Okay, then see what I can write. How many forces are acting on the system means the part of the chain on the table. How many forces are acting on that? First of all, its weight mg downwards. Mg means what I can write here. Let us take lambda is mass per unit length. Lambda stands for mass per unit length. In that case, thrust force will be equal to, just now we have discussed, V relative into dm by dt. In the place of that, lambda into V relative. That is lambda V square. Okay, thrust force. So apart from this chain weight, apart from weight of the chain, we are having now this thrust force also. The chain which enters into the system exert a force on the system downwards. See carefully. Chain is now entering into the system. So when it enters, force on the system will be in the direction of relative velocity. So it is now exerting force on the system downwards. So it is now lambda half part on the table. So lambda L by 2, that is mass on the table, into G, mg, plus thrust force. Thrust force is now lambda V square. Okay. And this force is equal to normal reaction on that table. Means what is normal reaction by that table on the chain? It is equal to weight of the chain on the table plus thrust force. Now see, in the place of V, what we can write? Half part on the table means velocity equal to root of 2 G H equal to L by 2. So V equal to root of GL. Okay. So lambda L G by 2 plus lambda V square. V square is now GL. It is now 3 by 2 lambda GL. Okay. In the place of lambda L, we can write mass, right? 3 by 2, 3 by 2 lambda Lm mg. Okay. Normal reaction is equal to 3 by 2 times weight of the chain. Okay. And here you can say one more thing, relation between thrust force. Thrust force, how much we got? Lambda L is lambda L. That is how much? Lambda L is M. This is mg, right? This is mg by 2. Okay. So mg is now thrust force. Normal reaction is 3 by 2 mg. Okay. So whenever having chain, what is thrust force means is lambda into v square, where v is velocity with which it enters into the system, or it is the velocity with which it is leaving the system. Okay.